Continuity describes a function that behaves smoothly at a point, without a break, hole, or jump. It is one of the fundamental ideas of calculus.
Visually, a function is continuous when we can trace its graph near a point without lifting the pencil. The curve flows smoothly through that point.
For a function to be continuous at x equals a, three conditions must hold. The function value must exist, the limit must exist, and the limit must equal the function value.
Polynomials are continuous everywhere. For this example, the function value at 9 and the limit as x approaches 2 is also 9. Therefore, the function is continuous at 2.
Consider the rational function x plus 1, x plus 2. At x equals 1, the denominator is not 0. The function value exists and both are equal to 2/3. So the function is continuous at 1. A rational function is continuous wherever its denominator is not 0. For 1 divided by x minus 0 at x equals 2, the function is therefore undefined and discontinuous at that point. This function has a removable discontinuity. After factoring and canceling, it becomes x plus 1, except at the graph has a hole at 1, 2. The limit exists, but the original function value is missing. We can remove the discontinuity by defining the missing function value. If we set f of 1 equal to 2, the hole is filled. Now the function value equals the limit, so the function becomes continuous at 1. A jump discontinuity occurs when the left-hand and right-hand limits are different. Here, the left-hand limit is 1 and the right-hand limit is 3. Since the two limits do not agree, the limit does not exist and the function is discontinuous at 1. An infinite discontinuity occurs when the function grows without bound near a particular point. For 1 divided by x minus 1, the graph approaches infinity or negative infinity near x equals 1. This creates piecewise functions require special attention. At x equals 2, the left-hand limit is 3, the right-hand limit is also 3, and the function value is 3. Now change the second part to 3x. At x equals 2, the left-hand limit is 3 while the right-hand limit is 6. Because the one-sided limits are different, the function is not continuous at 2. The sine function is continuous for every real number. At any point a, the limit of sine x as x approaches a equals sine a. Therefore, the sine function has no breaks or discontinuities. Differentiability and continuity are closely related. If a function is differentiable at a point, it must be continuous there. However, a continuous function does not have to be differentiable.